One thing I've been working on in my spare time is how to use these cell phones to do a triggered slow motion capture of some interesting event like a circuit breaker flipping. And well, what I did discover was a lot of cell phones, in particular the Samsung ones, have the ability to do super slow-mo frame rates, namely almost 1,000 frames a second for half a second or a second. And because the recording time is so short, what you have to do is trigger the cell phone just slightly before whatever event occurs that you're interested in. And it turns out you can do that using techniques used in normal cell phone headphone adapters, where the headphone adapter has some sort of a button to trigger the camera or the voice on the phone. Well, it's fairly easy to make an interface box to trigger the phone as if it was a headset. And so what I did was built this box that triggers the phone using a 24 volt AC input. The reason I use 24 volts is that's a pretty standard control voltage used in HVAC and automation, and there's a lot of things that can be used to generate the trigger signal. So in this video I'm going to show you how this trigger box is supposed to work. We'll build a box and we'll test it very briefly, and in a future video we'll look at the whole mechanism I built for triggering this box in sequence after doing something like turning on my 50 amp 240 volt welder, and then maybe triggering a light bulb, and then triggering the phone. So let's start off by looking at how the trigger mechanism actually works. So what we're going to do is use a clever little trick on the microphone or headset jack of a typical Android phone. And the way those jacks are set up, well, you can see one here, is there is what's called the tip, which is the tip of the connector, and then two rings, so R and R, and then the sleeves, so tip, ring, ring, sleeve. And it turns out that usually the tip here is the left audio channel, and the first ring is the right audio channel for the headset. And then, and here's the thing that we're interested in, this is the microphone ring, and it actually has a voltage across it and ground. This is ground. And the voltage is used to potentially power the microphone, but for our purposes it's used to detect whether or not there's a resistor between the ground and the microphone ring. And so what we're going to do is put a resistor in there like this and have a switch, and this switch will end up being a relay. And it turns out that if this resistor is 470 ohms, and there are a number of different resistors you can use to trigger the phone in different ways, but for 470 ohms, well, when you close the switch, nothing happens, but when you open it, it does trigger the camera start recording or take a picture function. So what we're going to do is indeed take that functionality, and we'll make this switch into a relay like this. And this is a 24 volt AC relay, and the reason we're going to use 24 volts is because that's a fairly typical voltage for a lot of automation controls, HVAC controls, and so forth, which means there's a lot of cheap devices we can interface with it. You of course could use any voltage relay you want over here, and so what happens is when we apply a voltage here, the switch will close, nothing will happen, but when we remove the voltage, the switch will open, and the trigger from the microphone cable on the cell phone will activate the camera app if you've got the camera app open, and either take a picture or a video. And before we do all of that, let's just prove it actually works. So this is a Galaxy S10 phone, one that I've been often using to take videos. close-ups for my videos. It's my old cell phone. And here's the TRRS connector. And I've got a breakout thing because I think this was actually for a video connection to some sort of a device, and these are the composite video and audio out. Well, we'll plug it into the connector over here like that. So we've now got this phono plug, the red one, attached between here and here. The center is the ring we're interested in and the outside is the ground. And I just have a short length of phono cable, and it might be hard to see. Well, there is a 470 ohm resistor right here, and if we close this like that, nothing happens. If we turn it on, well, there we go. The camcorder is now recording. Of course, we're not seeing much because it's sitting right on the yellow paper. And actually, I'm going to test this. I don't know if we can stop it with the same trigger. Yes, we can. That's great. So there we go. That's the proof of concept. And what we'll do now is actually build this circuit in a little box. So I've assembled here all the bits and pieces we need to do it. Here's the box we're going to use, and it needs to have holes drilled in the end for these two banana connectors, which are going to be used for the 24 volt control voltage. And on the other end, we're going to drill a hole for the microphone jack, the headphone jack. And, well, that's what it looks like with the holes in it. And this 24 volt relay, for a couple of bucks, will go inside like that. And we have our 470 ohm tiny resistor. It doesn't need to be so small, but that's all I had. And some hookup wire. And what we're going to do is we're going to use this test cable that we proved would work to help identify which ones of the pins on the connector are indeed the pins we should be using. And my guess would be is this long pin over here is ground, and it is. So the first thing we'll do is solder a green wire to the ground pin so that we don't forget which one it actually is. What I like to do is use these small clamping wrenches to hold things like this when I'm soldering them. You have to be careful because we don't want to squish the connector. There we go. So what we'll do is try soldering our wire to the jack. We'll just tin the wire a bit. I've tinned the jack. Now we'll find which one of the other pins we need to use. And so I'm going to use the voltmeter, or I guess the continuity tester, for the purposes of this test to figure out what the center wire is going to be. Okay, so let's see which it is. Looks like it's the one that's opposite the green one. We'll just look at the ones on the side here. Nothing there, and nothing there. So the pin that corresponds to this wire is indeed the one that's opposite the green. So we will proceed to tin that thing on the connector. That is the correct one. Actually, I should have taken this out so that it doesn't overheat. And we'll just use our clamp again to hold this in place nicely. And I'm going to use a nice yellow wire so that it sort of stands out as to what it is. There, it's nicely tinned. And there we go. Now what we'll do, maybe before we forget, is put the microphone jack in the box. And the reason I'm saying that is it would be all too easy to solder everything and discover that, well, we forgot to feed things through and have to unsolder everything. These plastic threads are always awkward to get on right. It's misthreaded right now. Okay, so that's nicely set. Maybe what we'll do is just tighten it a bit. Got to be careful here you don't strip the thread. So there's our nice connector, perfectly positioned. And if we sort of figure out how we're going to do this, I suppose the best way would be to have the relay situated like this. That way the metal parts of the connector are not likely to hit the pins on the relay. And we're going to have these connectors on the other side like that. How does that look? Probably pretty good. Is that sticking through too far? What I'm concerned about is that this... no, it should be okay. I was concerned that maybe the red part of the connector was sticking through too far in the case, and so we couldn't tighten it up right, but I think we're okay. Alright, well, I will worry about that later, maybe off screen, in the sense that what I may do is put a washer in here that's just a little bit bigger than the hole, or the same size as the hole, so that we get a good tight connection. We'll use these things here screwed onto there to make the connection to the coil for the relay, and these two pins are the coil of the relay, of the 24-volt relay. So what we'll do is we'll attach these two wires to the pins of the relay directly. Alright, so now we'll connect our control wires. There we go, they're attached to the relay. And attach a wire. So we've got our two 24-volt connectors all set up. What we do now need to do is find a good place that we can maybe secure our resistor, because we don't want it just hanging around. And let's just figure out what the pinout of the relay is. Well, these are without a doubt the commons over here, so they're 4 common connectors. So this is a 4-pole double throw relay, and these pins are the normally closed pins, denoted NC on a diagram, and these are the normally open pins, so they will be closed when the relay is activated. In other words, they're the pins that we're going to use for our switch. So maybe what we'll do is connect our ground to the common pin here, and it will connect to the normally open pin over here when we activate it. And what we'll do is we will take our resistor and maybe just position it so that it's soldered here and soldered to this pin, which won't be connected to anything. And what we'll also do is solder the wire from the microphone jack to that pin. So we're just going to use this pin as a mounting post, as opposed to having to use a separate mounting post in the box. So we'll solder this end of the resistor before it comes off. That worked. And now we'll solder the other end of the resistor. Now what we need to do is connect these two wires. There we go. So ground, and when the relay is closed, it will be connected to the resistor. The resistor goes over here. So what we'll do is connect the yellow wire to the other end of the resistor. There we go. So we have the wires that go to the cell phone connected, and we have the wires that will control things connected, and it will fit nicely. One other thing we need to do is have a way of securing the relay. Is there any space whatsoever in here? And I think not. So maybe what we'll do, I was going to use some double-sided tape, and I'm going to get some washers to secure these things better, and then we will finish up the box, close it, and test it. So what I did realize was what the problem was when I was trying to put these things through the side of this box, and that is I was leaving out these little washers that go over the end and indeed cover up any protruding lip of the connector. So now that I know what I'm doing, in goes the connector, and we'll put the washer that the connector people provided over it like that, and a steel washer and the nut. And I'm not sure how well you can see it. We'll try and orient it a bit so you can see what's going on. So we'll try and tighten all of that up. That's much better. So that's nice and secure. And now, electrically, all we need to do is attach our relay. All right, that's looking pretty good. I'll just position these wires so they don't get in each other's way. Stuff them all in. And before we close the box, what I'm going to do is I've got some electrical tape here, and we're going to use that to secure the relay. Now what I could do is use some double-sided tape on the top of the relay and the side of this box, but since I want to make sure that I can easily get the relay out if we need to make modifications later on, well, what we'll do is just use some electrical tape bent over, since I don't have any thin double-sided tape. That will be good enough, I hope. There is our magical little box that will hopefully trigger, well, the cell phone. And we're going to try that now. All right. I've got a bunch of things to test our device with. This is a 24-volt power supply. So I'm going to just plug this in under the desk, and we'll have 24 volts AC on the two yellow banana plugs. I also have here a big red button attached to banana plugs, and this button is momentary, so when I press it, it's on. What we'll do is connect our big red button to one of the inputs on our box, and we'll connect the other end of the button switch to our power supply, and we'll connect the power supply back to our magical control box, and we should hear the relay clicking when I press the red button. And I don't know if you can hear it, but I sure can. So all I need to do now is connect this to the microphone input on the cell phone over here, and we should be able to turn the camera of the cell phone on and off. Okay, I have a TRRS cable, connectors on both ends, And we'll plug it into our magical box like that, and we'll plug it into the camera. I should say cell phone camera. And maybe I'll get up so I can see what I'm doing. There we go. All right. If everything works as expected, when I press this, we should take a picture or take a video. And it's doing it. So right now we're not taking a video. Press the button in, which closes the relay, and nothing happens. Release the button, and it triggers it. So now we're taking a video, as we would expect, and we can then stop it by pressing the button again. And what we should try now, just for fun, is try SuperSloMo. Here we go. That's the SuperSloMo mode. And what do we have that's SuperSloMo? Well, I'm just going to be moving my fingers like this. So that worked. Now, the one thing that remains is to talk about which type of cell phones work well with this sort of setup. I've only looked at and experimented with Samsung phones, and it turns out that the S9 is the first one that had reasonable SuperSloMo, and the last one seems to have been the S23. The S24 seems to have abandoned it, and the absolute pinnacle of SuperSloMo seems to have been the Samsung S20, S20 Plus, and S20 5G phones. And what makes them so nice is they all had 960 frames per second, so almost 1,000 frames per second compared to the usual 30, and that at 720p for a total recording time of 1 second. So 1 second of SuperSloMo, which translates into many seconds of actual viewing time. The earlier phones, such as the S10, and the cheaper phones like the S20 FE, well, they have shorter recording times, and the really old phones, well, the S9, for instance, only has 0.2 of a second recording time, as near as I can tell, and that's not really long enough to be that useful, but the 0.4 second recording times of the next generation of phones is quite good. And the 1 second from the S20s, well, that's fantastic. Unfortunately, the S21s and later seem to do less and less in terms of SuperSloMo. The recording time was reduced, and then the frame rate was reduced. And I guess what's really been happening is people haven't been finding it to be a very useful feature. The other thing to watch out for is the Ultra version of these phones, which actually has a reduced SuperSloMo capability, apparently because the camera has way more pixels and is not nearly as well suited for SuperSloMo operations. So watch out for that. Fancier is not always better. Now, the other thing I should point out is some of the newer phones like this S20, well, they don't have an analog audio jack, they just have a USB-C connector, but you can get these little gizmos that produce a headset with microphone output, and it turns out they are completely compatible with the system we have created. So don't despair if your phone does not have an analog audio jack. So that's how to build a hardwired trigger unit for a cell phone, whether you want to use it to trigger a snapshot or regular video or SuperSloMo video. And in a future video, what I'll do is show you how to build a controller that can trigger a whole bunch of things in rapid succession, perhaps turning on my 200 amp welder, followed by a light, followed by triggering the SloMo phone to capture some interesting event like something exploding. I hope you found that interesting. If you have questions or comments, put them below. And if you enjoyed the video, please consider subscribing. It's always very helpful for a small channel like this one. And if you have suggestions for future videos, well, send me an email. Thanks for watching and see you next time.